Welcome back YouTube, Moskasara here once again, and for today's video we'll be covering a neat little trick to multiply polynomials. Now, when it comes to multiplying polynomials, there are two major ways of doing it, mainly the FOIL way and the grid way. Now, they're both pretty similar. However, I prefer the grid way because it's a little more organized. And I'll show you what I mean in a second. For the first one, we'll need to do the FOIL method. And in order to do that, we'll need to recognize that the FOIL means first, outer, inner, and last. And what does this mean, you might be asking? This is what it means. Basically, you take the first value from each of these, meaning the first thing here is an x and the first thing here is an x. You multiply them together. Then you take the outer values, the outer x and the outer 2, the inner values, meaning the inner 5 and the inner x, finally the last values, meaning this last 5 and this last minus 2. Remember that the sign is very important. So then in this case, x times x is x squared, x times minus 2 is minus 2x, x times 5 is 5x, and finally 5 times minus 2 is minus 10. And all we have to do is add these together to get our final answer. Now the highest possible term here is the x squared, so that's going to be what we lead off with. Then with just the regular x terms, we have a 5 and we have a minus 2x. We're going to add them together by simply recognizing that 5 plus minus 2 is 5 minus 2, which is plus 3x. And finally, we have minus 10 as the last term. So yeah, this is the correct answer. However, the grid method can give you the same exact answer, except it makes this a little more organized. I'll show you what I mean. Now for the grid method, you essentially want to make a grid. Thank you, Captain Obvious. But more specifically, since this has two elements, we'll give this two columns, and since this has two elements, we'll give this two rows. Now the header for this will be an x and plus 5 in order to match this, and x minus 2 in order to match this. So basically we do the same thing. We multiply each square. Since this column belongs to x and this row belongs to an x, we multiply x times x, x squared. X times 5, we want this one, so that would be 5x. X times minus 2, which is minus 2x. Minus 2 times 5, which would then be minus 10. Now the reason why I like this a lot is because it's easy to, first of all, make sure that you multiply only what you have to, meaning you multiply this x with this x only once, and then you mark it in a place where you know you won't do it again. Also, if you do make any mistakes, like for example, I forgot the sign here. If you notice, I kind of did that on purpose to show that a lot of times it's easy to miss this minus sign. And if we get something that's wrong, we can always make sure, like for example, we can make sure that x times x is equal to x squared, x times minus 2 is minus 2x, x times 5 is 5x, and 5 times minus 2 is minus 10. We can always make sure. This way we'll be sure that we have the correct answer, and if we don't, we'll know where we messed up. And now comes time for adding them. You'll always lead off with what's in this corner. This is x squared. notice that this is the highest power, so we'll lead off with this. And the highest power will always be in this corner. After that, you move in this direction. So that means you'll be doing this entire diagonal trick here. So that's 5 minus 2. Minus 2 plus 5 is a plus 3 with a regular x, since that's the variable of this diagonal. And finally, you have no x's here, so that's just a minus 10. And again, you have the exact same values being added to give you the exact same result. What's really neat about the grid method, though, is that unlike the FOIL one, it can be used for bigger, messier problems. For example, we can do something like x squared plus 3x plus 2, x squared minus 2x minus 3. Now you could do the FOIL method, however, using a grid is much easier. We'll just write here x squared plus 3x plus 2 and then we have x squared minus 2x minus 3. Notice that the highest power here is 2, so we'll always want exactly that number plus 1 rows or columns. Also, you'd kind of want them to be drawn a little more evenly and a little bit more organized than this, but as long as you can tell which square or which rectangle is in which column or row, then you're good. So you have x squared times x squared. Since you're taking these two x's and multiplying with these two x's, that'll be x to the 4th. X squared plus 3x is equal to 3x cubed. Again, notice how this is a 4, this is a 3, and you're immediately going to know that this is an x squared term. Mainly 2x squared. If you're doing it right, you'll know that if this goes from a 4 to a 3 to a 2, it goes down every time you move in this diagonal direction. So then we'll do the second one, which is x squared times minus 2x. So that would be minus 2x cubed minus 2x times 3x, which would be minus 6x squared, and finally minus 2x times 2, which is a minus 4x. And then for the final row, we'll do minus 3 times x squared, which is minus 3x squared, minus 3 times 3x, which is a minus 9x, and finally minus 3 times 2, which is a minus 6. Now again, this might look like it might take a while to add correctly, but if you remember, we have our special trick, meaning we know that this corner is on its own and each diagonal can be grouped accordingly. Now you'll know you did this right if these diagonals all have the exact same exponent on the x. Like for example, this is x to the 4th, this next one x cubed, then x squared, then a regular x, then no x. And adding them is really, really easy. We can just do x to the 4th plus minus 2 plus 3. That would be just a plus 1 x cubed. Again, minus 3 minus 6, that's minus 9, plus 2, that's minus 7. So that's minus 7x squared. Minus 9 and minus 4, that's minus 13x minus 6. And we can see that this can easily and efficiently give us the correct answer. And I'm going to do one more problem to demonstrate one more point. So now this is going to be x cubed. Hold on, let me make that a black pen again. Minus x squared plus x minus 2. And then we're going to do x to the fourth plus 3x squared plus 3x minus 1. Now if you notice, in this second term I have x to the fourth going straight to x squared. There's no x cubed term. However, for the purposes of this procedure, you just want to include 0 x cubed. Sure, that means it's just 0, but you want to include it just so you can have this natural progression going from to the fourth power, then the third power, then the second power, first power, and no power. And you'll see this right away in this new grid that we're going to make, which is x cubed minus x squared plus x minus 2 and x to the fourth 0x cubed 3x squared 3x and minus 1. Now again, so long as you know which columns are going with which rows, and you have the exact number of rows and columns that you would need, you should be good. However, here's a little trick that'll save a little bit of time. Since we know that all of these values are 0, I'm just going to mark them out as right now. 0, 0, 0, and 0. The rest, however, we still have to multiply. So fourth power and third power, that's x to the 7th power. X to the fourth minus x squared, that's going to be a minus x to the 6th. X to the fourth plus x, that's x to the 5th, and minus 2x to the 4th. And we can skip this entire row because 0. Now, after this we have 3x squared and x cubed. We'll say that then that's a 3x to the 5th, 3x squared minus x squared, that's minus 3x to the 4th, 3x squared plus x, that's 3x cubed, and 3x squared minus 2 would be minus 6x squared. Finally, 3x times x cubed, that would be 3x to the 4th. 3x minus x squared, that's minus 3x cubed. 3x times x is 3x squared, and minus 6x. Finally, minus 1 times all of these, meaning just switch the signs. Minus x cubed plus x squared minus x and 2. Now this might look like it might take a while to add, but remember, we have our grid. Meaning we'll take this corner and work it out from there. Meaning this should be x to the 7th, x to the 6th, x to the 5th, x to the 4th, x cubed, x squared. Again, this is why I want to make sure you have enough space. X and just the regular number now. This is why you need the row. You might not need any of these zeros, but you still need the row to make sure that all of these diagonals fit in place. So then let's get to adding. We have x to the 7th, that's what we're leading with, minus x to the 6th. 3 plus 1 is 4, so that's going to be plus 4x to the 5th. 3x to the 4th minus 3x to the 4th, so that cancels out, so then minus 2. Minus 2x to the 4th. Minus x cubed minus 3x cubed, that's 4x minus 4x cubed. Minus 1x cubed, and that's going to be minus x cubed. Plus x squared, 4x So that's going to be minus 2x squared. Again, this lets you check where exactly you're going wrong, meaning you can check if you, in case you did a multiplication error, you'll be able to spot it by checking, oh, does minus x squared times minus 1 really add up, multiply up to x squared? In this case it does, so there's no error here. And it also lets you check adding. And then finally we have minus 7x, because minus 1 plus minus 6 is minus 7, plus 2. Yeah, this looks like it would be a big, daunting problem, but this shows that you can organize something as big and intimidating as this. And sure, this might not look like the prettiest of answers, but it's still the correct answer, and you can make sure by making sure that your steps here, which you can see clearly, are done correctly. And that's basically the grid method. If you have any questions, please feel free to leave them down in the comments section below. And if you enjoyed this video, please let me know what you enjoyed about it. If you didn't, please let me know how I can improve my content. In any case, this has been Muskasar, and I hope you enjoyed the video. See you later, guys.